Good. So I think we can get started. So this session will be recorded. Because of that, also, if you have any question, please post them in the chat. So there should be a chat option probably on the right-hand side in your screen. So we will have a FAQ section in the end. So we will go into these questions that come in via chat, and there's also a colleague available that can see the chat, so I might also answer. So overall, it will be a short session. So we are focusing on the updates we did to the Confluent connector, we have three topics that we want to show. So one is a more general topic about a new option on sequencing of events. And then we have a dead letter queue support and the direct Kafka connectivity based on a TCP IP level protocol. So we want to quickly go over the feature and then show you in the system how it works. So first off, sequencing. So what does that actually mean? So in the current state of the framework and without the sequencing feature active, it is always, if a call, for example, fails, then we will at a later point retry. And once we have retried, or once we do the retry, we actually re-extract the data. So we always send the latest information at the point of the retry. For like most use cases, this is totally fine. So the subscribers always get the latest information from the SAP system. So there is no issue about have there been other events in the meantime that probably did go through. So something like that could have happened, and then you always get the latest info. But there are some use cases where you actually want to have every single change in between. So when there is a change in SAP, you want to communicate that out. And if that fails, then these re-extraction on at the point of time when the retry happens, that means if there have been any other changes in between, you will get just the updated data. So you will get both changes together in one event. And there are some use cases where that is cannot be tolerated. So that's where the sequencing comes in. And this, of course, it also affects if you have like high load and multiple changes in a very quick succession to the same object, then this also comes into play. But this is way harder to actually check on how that works. So what we actually do is that we basically limit who can send a certain object at a time. So just imagine we have this queue of events. So this is another thing the sequencing does. It will queue all the payloads into a new queuing mechanism. And so the ones on the left-hand side here, they have been already sent successfully. But the ones on the right-hand side is the current state of the queue. So there is like color-coded the different objects with different events. So there's object 1, which has 3 different events. And then there's object 2 with 2 events. And then there's a third object that has just 1 event. And those all potentially due to a connectivity issue, they have not been sent out yet. And so when there comes a new event, like the event 3 of object 1, we will go into that queue and check, do we have any other events for object 1? And then we also have a lock that only we can now send changes to object 1. So if at the same time some other event happens, So we were there first, so we have the lock, and if they run into that lock as well, they can't send, they just queue it. But if we got the lock, then we can send out. And what we typically do then, or what we would do then, is that we look, do we have other events for object one? And we find, okay, we have these event one and event two of object one. And then we do send it just in sequence. So we send first event one, then event two, and then event three, all basically in a quick succession, of course. But it's like you will have individual events on your Kafka topic for this object. And then if that is a reprocessing process, we also look at all the other objects. If it's just like happening before the reprocessing takes place and there's another event for the object, the same takes place, and we look at that, and then we only send the events for this object. And the reprocessing will then later catch up with the other events that are still not sent, and will then send them also in this sequence. So it will always make sure that for a certain object, all events are sent in the sequence that they entered our queue. So that way you will get in the receivers, you will get all the individual changes. So if there was a change to the name in event one, and then a change to quantity in event two, and then could be another change to the name in event three, you will still get the change to this name, and then the quantity, and then the change to the other name, just in that sequence. And if that is important for your use case, then this is where sequencing comes into play. Because yes, of course, sequencing, it will incur some additional costs, of course, like in performance. So we will store the payload somewhere. We have to check this queue, and although it is like not a high overhead, it's still an overhead that exists, and that the parallel send on the same objects, this is also basically needs a lock, and this can limit how much can be sent at a time. So to showcase you, as it is a little bit hard to showcase in the system, we do have a video that can be viewed, and we will check the video just now real quick so that you can see. So we have here configured. Yeah, probably want to turn off the audio for me. So we have an object here, and it is configured to run in sequence. And we have linked it to a material change, and it goes to a topic inside of our Kafka broker. And in the video, we will show that now there were some failures to send it. So we expect that if we now can resend it, that we then get this previous send attempt as well, so that you can see, okay, this is basically showing both arriving then in the end. And I probably could jump a little bit forward. So now we do a change to the same material, and we save it, and then this will trigger the event. And when the event is triggered, we get a new entry insight to the documentation how to configure it. So the next topic is support for dead letter queues. So perhaps just a quick explanation. What is a dead letter queue? So a dead letter queue basically means we do have a failure in posting our message, and that failure is somehow needs to be handled differently. So it either needs an additional investigation or manual investigation or an intervention. So you can define, if that happens, push it to a dead letter queue, and then there might be a process that looks into the dead letter queue, looks at the messages there, and investigates why they were failing. So typically you would not want that to happen in case of there's just an outage or just a connection error. So there are two ways to configure the system. And one way is to configure it to take place when a specific error occurs. So if you know there is a certain error answer from your broker in case this specific message cannot be processed, like it violates the schema, for example, that you have, then any kind of retries will not actually change that. So the retries will still produce a message that does not adhere to the schema, potentially. So you could have a dead letter queue that does not mandate the schema, but you can just post anything to it. And this basically is then happening when that specific error comes back. And there's also an option, like if it might be other restrictions that can't be pinpointed like that for certain error codes that come back. You also have the option to give a number of retries that have to happen before it gets posted to the dead letter queue. So this, of course, assumes that it's more like somehow this message has an error and it does not get accepted by the broker. And then after, for example, 5 retries, you will then post it the next time you will post it to the dead letter queue. So that way you have a dead letter queue in the system, and then can post it there. So typically how that can be easily reproduced is also a little bit time consuming. So we don't show in the system when that happens, because typically the easy way to reproduce it is have basically a non-existing topic that you post to and then runs into a timeout. And we do not want to change the timeout for that, but I can show in the configuration how you would configure it. So we are now in our SAP system. We do have an outbound object configured. So it is configured to talk to our Confluent platform instance. It is a material change. It uses a payload design to send the data, and it's linked to a material change event. And it has deliberately specified a topic that does not exist. And so typically when a topic does not exist, we will get a 404, or actually it could also be a 500 error message, if I'm not mistaken. So you might also want to add a second one here. So it's just basically separated, and then you can add multiple error codes. And with that being said, so if you now send it, then this will produce the error, and then the error will trigger basically the topic to change, and then to retry sending it to the dead letter queue topic, so which is just DLQ for us. So that's for the dead letter queue. So that can come in quite handy if you have like scenarios where you have these errors, and to push them to the dead letter queues. If you would want to configure with the retries, there's also another setting here that's called retries, and you can then give a number like do 5 retries, and then after 5 retries, if it's still not successful, it will push it to the dead letter queue. But it's always that the error codes, they take basically precedence. So if one of these specified error codes come, and you don't have to specify them, so you can also leave that empty or not have it at all here. So you can only configure it for the retries. But if you use error codes, then once that error code is detected by the response handler, it will try to post it to the dead letter queue. Good. And coming back to the slides real quick. Did I have them here? Then we come to the last big feature for the Confluent connector, and it's like we have now a new version of connecting to the broker. So the ones of you who already use the product know we typically need the REST proxy. So there's a Confluent REST proxy. We call via HTTP. We send our event payload to that REST proxy. And then the REST proxy posts it to the broker in the Kafka native protocol. And this is the first version where we implemented the Kafka native protocol. So you don't need a REST proxy anymore. It is using the Kafka protocol, which is a TCP/IP-based communication protocol, and it supports persistent connections. So just like with a WebSocket, for example, you will have a connection that stays open. So this, of course, helps quite a bit with an HTTP call, with a normal REST call, there's always overhead to do the HTTP handshake and all that stuff. And this is not necessary for these persistent connections. And this also means, I did not put it on the slide here, but this also means this only works if you have an S4-based system. So you have to have a modern SAP system that's based on the S4 or other platform foundation, so that you can utilize that, because for these persistent connections, we need the daemon process type that only exists in an S4 system. And to showcase that, we also jump into the system real quick. So we have separate connections. So this one was using our normal REST-based connectivity, but we also have a configuration using the Kafka protocol. Let me quickly scroll there. So you can see that, so we are using a different RFC destination than we used for the other one, and it's a different type of connector that you use. So as I said, it's S4 only because it uses S4 only technology under the hood here. But basically, you still configure the host name and the port that you connect to in your RFC destination, and you have to have the new connector to use it. So it will be an additional transport. So if you are interested, please check the download pages. There is an additional transport for these S4 only components, because they can't be packaged together with the components that also work on ECC. And for that one, we also have a configuration here. So configuration looks pretty much the same. So there is no change on how we prepare the payloads here. There's no change how to do the event linkage. So this also just links to a sales order change event. And we also just specify the topic. So there is, from the outbound object configuration, there's not really a difference here. The difference is just how it is handled because of the changes you did to the connection. So this also means, like, if you update your system and you want to configure it, then you can also use your existing outbound object configurations and then use that together with a new connection. And of course, there are a few caveats that were on the slides before. So currently there's no schema support as part of that. It's just because it needs to be communicated differently with the new protocol. So there might be some changes needed there. But so for now, we have a sales order change. So we just do a change to a sales order to simulate that, and then see how does that look. And I also wanted to open our broker to the sales order topic so that we can also see that. That we get the new messages in. I'll just let it reload so that it has no new messages for now. And then I just make a change because it was like, I don't know if you paid attention, but it was a change event that we connect to. So we have to do a change, like increasing that quantity of that item. And then once we hit save, the event will be fired, and we will get a new message. As you see, it's already here. So actually there were 2 events configured. I think actually that is the one that we were expecting. It's a little bit a more heavier payload compared to the first one. That's why it arrives second, because payload generation did take a little longer. And that one is a very small one. So it's a complete payload is visible here. And in the monitor, so you will also see it, of course, in our monitoring transaction. So if we go here, you will also see it here. It's Kafka protocol. Yeah, just execute it like that. And then we see, okay, we have here the sales order change. And you might notice there is some differences, and it's because like with these different protocols, the answer does not, so there's no request response cycle. And therefore the normal place where the cloud response occurs, it doesn't show up here, but it is a new place for where you can view the message IDs, and it will show here what was the response from that protocol, because it just comes asynchronously on the same connection, comes a response, and it's not like a dedicated request response cycle, because the whole connectivity is not part of the send process, or the not part of the process that prepares the payload. So it will be handed off to that persistent connection, and because of that we don't get an immediate response in that process and can't write it here, but it will be updated down here when that works. So with that said and done, I think we jump to the Q&A section. So I have not paid attention to the chat at all, so might want to have a look now if there are any questions. And I don't see any. Alex, I think you can also see the chat, right? If there are any questions. And if there are no questions, I think we just close the call. So video will be uploaded later, and whoever participates live will also get the slides with the links. So thanks, everyone.